Hi everyone. So, what we're going to look at today is connected particles. So, when two particles are being connected by a rod or a rope, a connection is happened, and that connection can either be a thrust or a tension based on the questions that you might get. So, I've prepared about 3-4 questions here to go through. And we'll go through them one by one. So, two particles P and Q of mass 0.3 kilogram and 0.5 kilogram respectively are joined by a light horizontal rod. The system of particles and then the rod is at rest on a horizontal plane at time t is equal to 0. A constant force F of magnitude 4 Newton is applied to Q, which I can see that here. So the force that's applied is 4 Newton, that's given. Q is 0.5 kilogram, P is 0.3 kilogram in the direction of PQ as shown in figure 3. The system moves under the action of this force until t is equal to 6 seconds. During the motion, the resistance to the motion of P has constant magnitude 1 Newton and the resistance to the motion of Q has constant magnitude 2 Newton. So there's some resistance they're talking about. Resistance is always opposite to the direction of the motion. So in this question, if I'm giving a force of 4 Newton this way, the particle is about to accelerate that way. So if it's accelerating that way, then the resistance have to be just the opposite side to the motion. So P has 1 Newton resistance, so 1 here, and then Q has 2 Newtons resistance there. So the diagram is now complete. Question is acceleration. So when you're doing connected particles, there's two things that you need to observe. When you're doing as a whole thing, you do F is equal to ma, which is Newton's second law, for the entire system. The force required to move the object is mass times the acceleration. So I'm moving the entire system using a 4 Newton force, and the force required is mass times the acceleration. So 4 Newtons of force is given to move the object forward, but although I'm giving 4 Newtons force, 2 Newtons of force and a 1 Newton force is obstructing the motion. So in essence, I'm only giving 4 minus 2 minus 1. That's the resultant force that I'm giving to this system for it to move. The mass is the total mass 0.5 plus 0.3. And the acceleration was not given in the question, therefore I'm going to keep it as A. 4 minus 2 is 2, minus 1 is 1, is equal to 0.8 A. Therefore, A is equal to 1 over 0.8. And that's 10 over 8, which is going to be 1.25. So acceleration is 1.25 meters per second squared. The speed of the particle at t seconds, t is equal to 6 seconds, is the part B. So what's happening there is they're asking about the speed. So I'm thinking about using suvat because the acceleration is constant. So if the acceleration is constant and the time is 6 seconds, initially it was at rest. It was given in the question, rest. All they're asking is the speed, final velocity. So u, v, a, t. Out of the 5 formulas from SUVAT, I'm going to be using v is equal to u plus at. V is unknown, u is 0, a is 1.25, and t is 6. .5 meters per second. Part C is asking the tension in the rod as the system moves under the action of F. So originally, I did not mark the tension. So tension is a pull. So this object is being pulled by the force that was given here, the 4 Newton, will be pulling this object, and likewise this object is going to be pulling this object. So tension is always inwards, and we'll look at part D or part E is about thrust. So thrust is opposite to tension. But when they ask for tension, we've got to disconnect this particle into 2 parts. So if I just draw how P would look like, so that's P object, 0.3 kilogram, and 1 newtons of resistance is still there, and I'm thinking there is a tension being pulled. So in here, I'm going to apply F is equal to ma for P only. So if you may see, I applied F is equal to ma in the first question for the entire system. But to find tension, you can't apply it to the entire system because the tension cancels each other. So as an overall system, the tension negates both sides. Therefore, we cannot use F is equal to ma for the entire system to calculate. So when you do F is equal to ma for the entire system, do not put T as part of your calculation. So you've got to disconnect this system into 2 parts, and then you've got to apply F is equal to ma. So T is the force that's given to pull the object forward, minus 1 newtons of force is given backwards. That is equal to 0.3 times the acceleration, and we've already calculated the acceleration as 1.25. And if I resolve this equation, I would have 0.3 times 1.25 add 1. And that should give you the tension. 0.3 times 1.25 is 0.375. And to that answer, if I add, is 1.375 newtons. That's the tension. At 6 seconds, the force is now removed and the system decelerates to rest. The resistance to the motions are unchanged, and they are asking the distance moved by P as the system decelerates. So part D is another SUVAT. Now what's happening is we are removing the 4 newtons. So 4 newtons is not there. So if the 4 newtons is not there, first thing is acceleration is going to change. So I'm going to do F is equal to ma for the entire system again. For this part, Forward force is 0 because we've removed the 4. And then 2 newtons is still there. 1 newton is still there. And then 0.8 is the total mass times the acceleration. So minus 3 is equal to 0.8 A. A is equal to minus 3 over 0.8. And that's minus 3.75 meters per second squared. That's your new acceleration. So minus 3.75. We know the final velocity at the point when the force is being removed. At 6 seconds, we've calculated in part B. So always related back to the previous question. What happened at 6 seconds is the velocity was 7.5. So I'm going to use that as the initial velocity, 7.5. And they said the system is coming to rest. So 0. And the question is displacement, or the distance moved, by p. So SUVA, which is v squared, is equal to u squared plus 2as. And v squared is 0, u squared is 7.5 squared, plus 2 times a is minus 3.75, and then s is the question. And here, I'm going to bring that to the other side. 2 times 3.75, s is equal to 7.5 squared. So s is equal to 7.5 squared over 2 times 3.75. So here, 7.5 squared, 7.5 squared divided by 2 times 3.75, which is 7.5 meters. Then they're asking the thrust. So now the object is decelerating, no forward force. So there's an object here, there's an object here. The forward force is 0. Here it's 2, here it's 1. But this time they talked about thrust. So I've marked with an arrow opposite side to the tension. So T here, and then we know that particle is 0.3, P is 0.3, and then Q is 0.5. I'm going to disconnect this because, as I've previously mentioned, you cannot find tension or thrust by doing it to the entire system. So I'm disconnecting this particle, and I'm going to keep doing it for P this time as well. So 0.3 here, and then thrust here. So I'm going to put T dash, then it's easier. So a forward, F is equal to ma. Object is still moving this way. It's decelerating basically. So we've calculated the deceleration as minus 3.75. So forward is nothing. Minus backwards is T dash. Another backward force is 1 is equal to mass is 0.3 times minus 3.75. And if I solve this, so let's do 0.3 times 3.75, which is 1.125 with a negative, minus T dash minus 1, and minus 1 plus 1.125 is equal to T dash. And that's going to be 0.125 newtons of thrust is given. And you may observe that I have put the arrow the other way around. In the previous question, when I was finding the tension, I did put the arrow the other way around. So T minus 1 in that question. And in this question, I have done 0 minus T dash minus 1.